All right, today's lesson is using the law of sine to solve non-right triangles. Recall there are two types of non-right triangles. We have the obtuse and acute. The obtuse triangle is an angle that's wider than 90 degrees and 180. It's between those two. And the acute is angles that are between 0 and 90 degrees. And these are the two type triangles we're going to deal with. There are only two situations when we can use the law of sine. And that's angle, angle, side, and angle, side, angle. All right, given the triangle below, solve for the missing sides. Well, I'm going to use the fact that in any triangle, the interior angles must add up to 180 degrees. So that means that 120 plus 40, that gives me 160. If I subtract that from 180, that gives me the third angle. So that gives me 20 degrees. Okay, so what I'm going to do now is I'm going to apply the law of sine. So I could say sine of A over A is equal to sine of C over C. So I'm going to say the sine of, well, we know this is 40 degrees. Angle A is 40 degrees. We know side A is 12. I know that angle C is 20 degrees. So I'll put sine at 20 degrees. And we don't know what side C is. So this is our setup. And what we're going to do is we're going to solve for C. So recall, this is our equation. And we're going to solve for C. So you're going to cross multiply it. So you can get C sine of 40 equals 12 sine of 20 degrees. And if you divide both sides by sine of 40, you're going to get C is equal to 12 sine of 20 over sine of 40. So, if you plug in the numbers, you can get 12 times, and sine of 20 is roughly 3.342, and sine of 40 is 0.643. And you're going to simplify that. So recall C is, and you can get a calculator to do this. All right, so C is going to equal 4.104 over 0.43, which means C is going to approximately equal 6.383. Okay, use the law of sine to measure the length of C on the triangle. And similarly, remember the triangle, the three angles must add up to 180 degrees. So 91 plus 28 equals 119. And I'm subtract that from 180. That gives me 61 degrees. And you just apply the law of sine. So I could say sine of B and I could set that equal to sine of C over C. So look, you know, sine of 61 is to 5. And we got sine of, angle C is 91, right? And we're looking for side C. So what you're going to do is cross multiply that. Is what you have there. So you can get C is 5 over sine 91 over sine of 61 degrees. And if you simplify that, you're going to wind up with roughly about 5.7. Let's start with the real-world application. Two ships 1,600 feet apart detect a submarine directly between them. The angle of depression from the first ship to the submarine is 40 degrees, and the second ship is 28 degrees. How deep is the submarine? All right, so it's always good to have a picture when you do problems like these. So we have the first ship, and the angle of depression from this ship to the submarine is 40 degrees. And you have our second ship. The angle of depression is 28 degrees from this ship to the submarine, and they're 1,600 feet apart. And like I said before, you know, all three angles in this triangle must add up to 180 degrees. And if you add these two up and subtract that sum from 180, you're going to wind up with 112. And what we're looking for is how deep the submarine is from the two ships. How deep is it from the surface of the water? So what we need is the height. That's what we're looking for. So this is what we're looking for. It's a height from that submarine to the surface of the water. But we need to know, let's say, what this exact length is, let's say from the second ship to the submarine. So let's set this up using the law of sines. So I could say, using the law of sines, I could say sine of 40 degrees, I'm coming from this direction, is to x. And sine of 112 from here to here is to 1,600. And if you solve this won't tell you the height, but it's going to lead to what the height is. But first you have to solve for x. And if you cross multiply and you solve for x, you're going to wind up with this expression. 1,600 times sine of 40 divided by sine of 112. And if you solve for that, you're going to wind up with this amount, 1,109 0.8. And we're going to use that to solve for the height. Okay. So recall that x is, in this case I'm going to put it down here, x is 1,109.8. And what we're looking for, remember, is the height. So now that we know what this side is, we got to figure out what this height is. So I'm going to take the sine of 28 degrees. And remember, that's equal to the opposite over the hypotenuse. So in this case, my opposite side is the height. That's what we're looking for. But I needed this information in order to solve this. So my hypotenuse in this case will be this amount. All right, and h is going to be so you take the sine of 28, which is roughly about 0.469, and you're going to multiply it to 1,109.8. That's a decimal there. All right, so when you do that, it's going to be approximately 520 feet. All right, that ends our lesson for today on laws of sine to non-right triangles.